Okay, guys. Everybody get your notes out again. You will want your calculators again today. And hopefully we'll get through the rest of the notes today. We'll be able to finish them. Oh, okay. Anybody else not get the notes last time? You left it. So do you see the 8th period folder? Yeah, just grab one of it. All right, guys. So if we were on number 5, I think that's where we were. What does it mean to have 95% confidence? 95% confidence level. You're just talking about sampling and doing this process over and over and over and over and over. You would capture the truth in 95% of those samples. That's what the confidence level is talking about. It is not talking about one sample has a 95% chance of getting the true mean or proportion in there, okay? It's if you did it a whole bunch of times, you'd have the truth in your window 95% of the time, okay? What number 6 is telling you here, this is how you answer your free response questions. So this one, this is how you answer, okay? So you always start with, we are whatever percent confident that the true, whatever mean or proportion you're talking about, with your context of the problem, and then this is the interval you get, and units if you have units and whatever you're talking about. I know that's a very generic version of that, but you'll see when we do a couple of them. That's how you read. I don't know, it's the collective, we're all in this together, I guess. You could say I if you want to. And again, part B there, you are not going to say there is a 95% probability or 95% chance. Don't ever use those in your answer. Always say you're 95% confident, okay? So just get in the habit of using the right wording there. And if you want to make your confidence interval narrower while increasing your confidence level, remember we talked about having a wide interval gives you high confidence because you've got this really big range to try to gather the truth in. If you're low in your confidence, it's probably a really narrow window. We can narrow it with a high confidence if you increase your sample size. Okay? Think about when you did your sampling distribution, how increasing sample size reduced variability and made it like a narrower shape. That's the same thing that would be happening here. And then solving for sample size, this is pretty much the only time the whole year that you're going to have to use any sort of algebra skills in this course. So we have to be able to solve for the missing variable in this equation. And we'll do an example of this on the next slide here. But you're basically going to solve for n in this equation. So there's a little bit of algebra here. You might not know what p is. If that's the case, you always assume p is 0.5. And now again, this is just for solving for sample size. This isn't in every problem, just if you're trying to solve for a sample size.
What is MP?
Margin of error. So that's, you hear like a polling question with plus or minus this margin of error. Like that's what it's talking about there. And we've got formulas for that. So let's go ahead and turn the page and we'll look at what all of these margin of error things and everything means, okay? The next slide here. So your point estimate, we talked about that last time. That's always either the X bar or the P hat. So if someone says find the point estimate, that's not some new thing we're trying to figure out. That's X bar or P hat, which you're used to. And then you have plus or minus your either Z crit or T crit, your critical value there, times your standard error. This whole thing that is being plus or minus the critical value times standard error, that is margin of error, okay? And it's written out for you with solving for sample size, but just so you realize that thing you're adding and subtracting to your point estimate. So let me give you, let's just make up one for solving for sample size so you can see how the algebra works here. So let's say we are 98% confident in something. So that's our confidence level. And we want our margin of error to be plus or minus 3%. So what I'm asking you here is, based on that, what is our sample size? Like, what sample size do we need to make that happen? Okay. Yeah.
What is it say next to confidence?
Level. We're going to just assume this is a proportions problem. We don't know P hat. We don't know any of that. So we're just going to be using this little equation that's right up here for you. So let's plug in what we know. So margin of error, that's going to go on the left side. What is our margin of error? 3%. How do you think I'm going to write that in an equation?
0.03.
Yeah, good. So 0.03 equals my critical Z value. So this will be good practice from what we were doing last time. 98% confidence level. Can you tell me your critical Z value? Look in your notes if you need to, if you jotted down how you did this on your calculator. Let's see if you can come up with it.
Plus or minus 2.326.
Good. I have 2.33 written down, so yeah. Do we need a reminder on how we find that? Yes, okay. I'm seeing some faces that just look. Okay, so 98%. Remember, make a picture if you need to, just to like remind yourself of what you're doing. When I'm talking about that confidence level, I'm talking about the middle 98%. What percent does that leave, like, do you have as leftovers? 1 on each side, right? Because you have 2% left, so that's 1% here. I can't write today. 1%. And the other 1% is up there. I like to just use the first value because it's easy. We're looking at 0.01. What do you use on your calculator to get the Z-score?
Inverse norm.
Inverse norm. Okay. And then the area you're looking at is 0.01. Let me pull up my calculator for you too, just to make sure. You guys remember where inverse norm lives on your calculator? Okay. Okay, good. So 0.01 for 1%. Mu and sigma, leave them alone. Okay, you could have also done 99%, and you could get the same answer. Yeah.
For the mu and sigma, will it always be 0 and 1, or will it sometimes be different, but they'll tell you it's different?
If you're looking for the critical z-value to do any of these, it's always going to be 0 and 1. Because you're always going from the normal distribution, standard normal, that's it. Okay. All right, are we okay with that part then? Yes, okay. All right, so back to our algebra here. So I've got my 2.33, and then it is, maybe, times the square root of 0.5 times 0.5 over n. Okay. Algebra land here. I'm not going to key a bunch of stuff into my calculator along the way and have all these decimals that I'm rounding. We'll just key it in at the very end. So the first thing I have to do is divide both sides by that 2.33. And then over here I've got the square root of 0.5 times 0.5 over n. What do you think we do next? Yeah. Yes, square both sides. Yeah. Totally fine. It's technically plus or minus, so I could write that in. And then doesn't matter, because what's going to happen in this step? You see it? Yeah, when you square it, it's going to become positive, so it doesn't matter. You just need the number part of it. All right, so now I've got this awesome 0.03 over my 2.33 squared. And over here I have equals 0.5 times 0.5 over n. Yeah.
So you want to swap the n on the 0.03.
Yes, exactly. Because you're multiplying both sides by n and then dividing by that crazy fraction. I'll show it in 2 steps, but you guys certainly don't have to write it in 2 steps. So multiply by n. So then we've got 0.5 times 0.5 divided by 0.03 over 2.33 squared. All right, that's what you have to key into your calculator. Let's see, about what do we think our sample size needs to be? And do you think we should have like decimals of people? No. What do we get, guys?
1,508.
Okay. 1,508. Is everybody there? Okay. You could even tell me about 1,500 and you'd be okay, but safer to go over rather than under on your sample size. We always like bigger sample sizes, right? So 1,508 is fine. You could say about 1,510. I would take that. Okay. Again, it's very different from calculus. We're not rounding to 3 decimal places, anything like that. But that's the general idea. That's the extent of algebraic work you'll have to do in here. Manageable? Okay. All right. Let's turn the page and just do a couple of confidence intervals now. Any questions before we jump into this one? Okay. All right, so first one here, you're given a simple random sample of 1,100 males, get their ages in the US, whether they played massive multiplayer online role-playing games. Apparently we're calling those MMORPGs, because that's so much shorter. It's a lot. So we've got 775 said they did, and we're going to make a 95% confidence interval to estimate the proportion of all US males who play MMORPGs. Okay? It's not an acronym I'm super familiar with, guys. So more this, yeah. Okay, so let's, above the problem, I'm going to write out everything that we know. Do we know P, like the actual population proportion? Gabby says no, she is right. We don't know that, okay? We're not sure what P is, but do we have P hat? Yeah, okay. What is that? What is my P hat? Yeah.
775 over 1,000.
Yep. 775 over 1,100, which comes out to 0.7045. That seems like more decimals than I really want to write, but that's okay. And then it's also good, I know we wrote it in figuring out our P hat, but let's write down our sample size too. So that's 1,100. Okay. That's sort of all the information we need and we have to work with. When you're doing a confidence interval, you want to check your conditions, just like we were doing with our sampling distribution. So that's where I'm going to start next. I'm going to do conditions. And they are the same conditions as last time, okay? So, is it random? Yeah, it's stated, right? Doesn't it say simple random sample? So you're going to say SRS stated. That means simple random sample stated. Okay, normal. How do we check normality when it's a proportions problem? I remember. Mm-hmm. Perfect, yep. And guys, when you're checking that condition, you don't just write n times p, n times 1 minus p, check, like, no, you have to actually, like, write out your numbers, too. So I'm going to do n times p hat, which would be 1,100, maybe. Times our 0.7045. And we need that value, which should be 775. Yes, that is greater than or equal to 10. N times 1 minus p hat. 1,100 times 1 minus 0.7045. That's 325, guys. You can actually multiply, or you can go, oh, it's the rest of the 1,100. It's the ones that don't. Okay, that's fine too. Also greater than or equal to 10. So we are good on random and normal. So our conditions are good. Then it's, you can't proceed. Yep, because you're using this critical z value and everything from a normal distribution. And so it wouldn't make sense if yours isn't normal. Yeah.
So he is not going to use p-hat.
Yep. Yep. All right, we good so far? Okay, I'm going to show you this one kind of by hand and with the formulas, and then I'm going to show you how you can just do the whole thing on your calculator too. But there are pieces of it that even if you do it all on your calculator, you still have to write down to get full credit on the free response, okay? So first, what is my critical Z value for 95%? That's one we found the other day, or you can use your calculator. Good. Okay, so our formula for doing a confidence interval is p hat plus or minus z critical z value, times the square root of p hat times 1 minus p hat all over n.
What is that the equation for?
That is your confidence interval. So you can just plug in everything that we know. So 0.7045, that was my p hat, your point estimate. Plus or minus, you found your critical z value, 1.96, square root of 0.7045, 1 minus 0.7045, all over 1100. You guys see it okay? All right, not the funnest thing to plug into your calculator, right? Yeah.
How do you know if it's plus or minus? Because you're not supposed to when you're doing by hand, you know,
Yeah, when you do, if you do it by hand, you would do 0.7045 plus 1.96 times all of this and get one answer. And then do minus, and then shoot the other. And those are like the endpoints of your interval then, okay? And does that make sense then that the 0.7045 would be right in the middle of those two values that you got? Okay. All right. I don't like keying it in either. Yeah.
How did you get the 1.96?
So that is the critical Z value. So 95% confident what you're doing. This is the middle 95% we're talking about. So that leaves 2.5% on each end, right? Does that make sense? Okay. So you're doing inverse norm to find the z-score that goes with 2.5%. So your area is 0.025. So if you do second distribution menu, or second bars takes you into the distribution menu. And then here, I'll pull up my calculator because we need it here in a minute anyway. So second distribution, see that inverse norm? And so you do 0.025 for 2.5%. And you get the 1.96, negative 1.9. Are you getting?
I got it 1.6. Oh, it was a big difference.
Oh, okay.
Yeah.
Got it? Okay. All right. You absolutely can do plus, minus, key it all into your calculator, but I don't really want to. So we're going to do all of this on your calculator. So go ahead and click on Stat for me. And then we're going to go over to Tests. So we've got a bunch of tests, Z's and T's, and then two samples and proportions. But then I see interval. I see a Z interval, T interval, one proportion Z interval. Okay, we're doing proportions, right? We just have one proportion. That's the one I'm going to pick. So one proportion Z interval is what you want to use on your calculator. So I click that. Okay, X, that's your number of successes. So how many people said they played these games? Yep, 775. Oops. And then N, you're out of 1100, right? And then you can change your confidence level to whatever you need it to be. Mine is at 0.95, and that's what I need. But if you were looking for a 99% confidence interval, anything like that, it will, you can change it and it'll calculate that for you. Then I click calculate. It gives you your interval here, your 0.678 to 0.731. Anybody having calculator troubles and not getting to this? Okay. Yours might not do. So oh, it's not we'll go over there. There you go. Yep. Anybody else? That's your interval. Okay. Sure. All right, then what do we do with this answer that we got? So, all right, so you can jot down like this equals, and then just put your little interval, 0.678, comma, 0.732. So you know, like, hey, I got this actual interval. And then we answer it with the context and everything from the problem. So we would say we are, and I don't think I have room to write it here, so let me go to a new slide for you. We are 95% confident that the true proportion of 12 to 17-year-old U.S. males that play MMORPGs is between 67.8% and 73.2%. Does that kind of make sense how you just fill it in? And it's going to look very similar every time you write this. You're just going to change out your confidence level and your context. But we're saying the true proportion is somewhere in between 67.8 and 73.2. Okay? Now, back to this part. If you are doing it on your calculator, like you're just plugging this in, you still have to write a bunch of this stuff down. You still have to give me the critical Z and the formula. You don't have to write the formula with the numbers in there. If you'd rather do that instead of just the formula, you can, but so one way or another, you have to represent the formula, but you don't have to show it both ways. And you obviously still have to answer what the interval is, okay? Conditions, all of this stuff at the top, okay? You still have to show all of that, even just doing it on your calculator, okay? Questions on the first one? Okay, try letter B for me here. Now we want to know sample size, so you're going to try another one of these sample size problems. Suppose you want to estimate the proportion who play with 95% confidence within 2% for your margin of error. How large a sample size would you need?
So for this one, is this where you like use the 0.5?
Well, but this one, do we know our p-hat? Yeah. It's true, we don't know P. You could do it. Honestly, on the test, the way it's going to be given to you is where you have to do the 0.5. In this, yeah, let's do it with the 0.5 because what we have, the 0.7045, that's with it being out of 1100, and since we don't know our sample size, it seems strange to have it out of 1100. So go ahead and do it with the 0.5 in there for me, okay? So remember your formula. Margin of error equals your critical z-value times standard error, and then reminder of what standard error is. That is p-hat, or p in this case we'll do 1 minus p over n. Do your 0.5s in there for me, okay? So you guys try it, check with each other. Do you think you've got it? Let me get attendance taken.
Do we need to write out the steps like as much as we did here?
I did more steps than you really have to write down. I just wanted to make sure I didn't lose anyone along the way with the steps, because we have a broad range of like what your prior math class was to this one, you know, so we have people who are in multi right now along with this, to people who took trig discrete, you know, like there's just a huge range. So I just want to make sure with the algebra stuff I don't leave anybody behind. Yeah, you'd want a sample of about this big, and that's it. Yeah, there's no like big contextual conclusion on this one. Again, check with each other once you're done. Now, you have a calculator, right?
Yeah, I do. I just forgot to do it.
Okay.
Oh,
That's the thing I don't like with the rechargeable ones is there's no like, oh, I can just change battery.
Yeah.
If you forget to charge it, it's just.
Plus, like, since it lasts so long without needing to be recharged, whenever it does die, I like constantly forget because I'm not used to having to charge it like I do like my computer. So.
Yep, yep.
on the 90% pump level, it is, since you never personalized to it, online, you only have like. So, the first is not in that console because that also for your money. That's like the error bars and the extra point or two. And
The easier.
yeah, you always really get you don't have it. Yeah. And then you plug that into your new.
Did you guys get a sample size for me? What do we get?
2,637.
What, everybody, I'm fine with that, but other answers?
2,401.
That's what I had, but did you do more decimals on your
Wait,
critical Z value?
do you find it 95 or do you like to put
You do 0.02, but your critical Z value, what did you use for that?
I put it in the inverse norm and put the area as 22. Or you don't do that.
No, so two different pieces. Okay, good question. The 0.02, that is this side. The critical Z value is for the 95% confidence level. So that explains why you're close, but not because 95 would be 0.025 and you did 0.02. Do you see it? Because like on the last one, we had 0.03 equals 1.96 times.
Maybe I'm just doing it like this. And have the MES 2%.
The ME is 2%, margin of error is 2%. But the inverse norm only came into play with the 95% confidence. It doesn't come into play with the plus or minus the margin of error part, okay? Ethan?
For the secret, is it just assume that it's going to be positive?
It doesn't matter. You could use positive, negative, you could write plus or minus, because in the process of solving it, you square it every time. So it's whatever you feel like writing down. Is there a question over here too?
Yeah, since this is like kind of like a two-part problem, we don't have to show the Z crit or crit CV calculation again, right?
That's fine, yeah.
We can just like plug it in.
You really don't ever have to show it because a lot of people will just, you know, on the formula sheet I give you with every test, there's tables on there. Some people like to just look it up in the table as another way that you can go about doing it. So, and we'll look at that later. All right, are we okay then getting about 2,400 people? Yes? 2,401. We're okay with that? I know you're finishing now. Did you try it again or? Did you try it again? Or are you good? It's okay if you understand it. I mean, very little, really. If you understand, like, I would go from this step to, I know n is going to be 0.5 times 0.5 divided by 0.02 over 1.96 squared. Like, my brain goes from that to that, but it's fine to show. Are we okay? You guys are very quiet, so. Yeah. Not really when it's a sample size question. It's just how many do you need? That's about it. And always approximately this many. Don't ever tell me like we need 2,389.2 people like that. No, that doesn't make sense. It's okay. Do you need to what? I'm sorry. Like writing the formula?
Yeah.
Not really. As long if you're showing either that step or this step is fine. Yeah. If you just write an answer, I'm gonna go. How'd you get here? Okay. So show me this much. All right. Other questions before we try the next and last confidence interval one in your notes? Okay, let's try again. All right, now we've got National Fuel Saver Corporation. They've got Platinum Gas Saver that could increase gas mileage by 30%. So they installed this device on 15 identical randomly selected vehicles and found the percent change in gas mileage for those cars. So that's what this data is here. These are 15 different cars and what happened with their gas mileage. Okay, construct a 90% confidence interval for the average percent change in gas mileage. So we have to decide from the beginning, is this a means problem or a proportions problem? It is means, yes, good. It would make sense to average those, right? So, means, okay? Just like we did with the proportion one, let's write out what we know, what we don't know, so we can kind of make sure we've got all the information laid out for us. Okay, so do we know mu? Like, do we know the population parameter? No, we do not. It's very common to not know anything about the population. Okay, usually you've got your sample, and maybe nothing else with it. That's okay. So if we don't know mu, what do you think? Do we know sigma? No, we do not. Okay. All right. That leaves me with X bar, S, and my sample size. Do we know sample size? 15. Good. Could we find the mean and standard deviation of our sample? We could, right? Do you guys remember using the 1-bar stat? Okay. We can do that. We can also find all of that in the process of doing this problem on your calculator too. Either way, you have to put this list into your calculator though, okay? All right, so we'll come back and fill the rest of this in a moment. Let's check our conditions. Okay, is it random? Yes, it says randomly selected vehicles, so yes, stated. Okay. All right, normal. Any thoughts for normal? Yeah. Okay, so we can't use CLT. You are correct. And do we know anything about the population? Like, do we know the population's normal? No. Does anybody remember the third option? Yeah, Miranda. Very good. Normal probability plot. Okay. I'll walk you through how to do that because I'm guessing not a lot of you remember where that is. So on your calculator, we need to put these lists, these values in a list, okay? So I clicked stat, and now I'm going to push edit. I'm going to put them all in list 1. If you already have something in there, you can just type over it. You can clear a list, but don't delete a list. So I'm just going to start putting them in. I'm sure you guys will go faster than me. All right, we've got all of our numbers in. So do we have all of our numbers in? I'm not sure everybody's okay. So let's go to our normal probability plot. The way you do that is second y equals, and that should take you into the stat plot. Okay, I'm going to pick the first one. Mine says off. I need to make sure it's on so that it will actually graph something. And then do you guys remember which type is the normal probability plot? Last one, yeah. So I just arrow over to the right until that's highlighted. Okay, my data was in list 1. Leave your data axis as X. Your mark is fine. I'm going to push zoom stat, which is zoom 9. And there is my normal probability plot. Okay. We're not looking for perfectly linear, okay? I don't love this point, right? I feel like this guy makes it a little questionable. But is it approximately linear? It's close enough, yes. What you would see if it's not is you would see like this very like, you know, if I had these points going on and you're like, wow, that kind of looks like a parabola. Like that is not linear, okay? This, it's close enough. Not exact, but yes, we would go, okay. That's close enough that we can say this is normal. Now, while we've got our list in here, just for practice, let's do our one bar stat to make sure you guys remember how to do that so we can find our X bar and our S. So guys, where do we go to do the 1 bar stat? Anybody remember? Yep. And if you forget, just try, like push something and you're like, oh, okay, there it is. That's fine. Stat. Oops, not test. Calc. And then it's the first one there, 1 bar stat. List 1. Did not have a frequency list. Calculate. There we go. So you've got your X bar. And guys, which standard deviation am I using from this? I'm using the S sub x1, yeah, because this is my sample. So that's the one I want. All right. Let me fill in some things here. So X bar, I think it was 29.43. Your standard deviation was 16.24. And for our normality down here, we can say normal probability plot, NPP, is approximately linear or roughly linear. So now we've got our conditions. All right, we're going to do the interval on our calculator, but we still need to write down our formula. So I've got a 90% confidence interval. That's what I'm finding. What is my formula? So yeah, flip back in your notes if you need to. You've got 3 choices here. Which formula do you think it is? Yeah, I agree. Say it again, sorry. I want a whole equation. Yes, yes, the one with the T, yes, okay. So it starts with X bar, because it's a means problem, right? We need that point estimate. Plus or minus, you're absolutely right, it's the T crit one, the critical T value, which is multiplied by S over the square root of N. Okay, so we need our formula. Guys, why am I using the one with a T? Yeah, I don't know sigma, right? I do know S. I've got that. I can find that from my sample, but I don't know sigma. Anytime you don't know sigma, you use T. Okay, you absolutely can do this by just typing in the X bar and the T crit and the S and your N, all of that, into your calculator and getting your interval. Let's look at how we could just do the whole thing on the calculator, though. Oops. So, where do I go to calculate an interval? Stat, yep, and then I look at calc, I'm like, I'm not seeing anything there that looks like. It's under the test part, okay? So you'd push stat and then arrow over to test. And then we've got to arrow down. We're looking for intervals. Eventually we'll use all of these other test things in there, but not right now. That's when we get to hypothesis testing. We are in the interval part. So I've got Z interval, I've got T interval, 2 samples, proportions, all that stuff. Which one do you think I should use? Yeah, T interval, right? That's what we're finding is a T interval. So I'm going to pick that one. Okay, you have the choice of putting in your values as data, which means a whole list of them, or if you have the stats given to you, like you know X bar and sigma, all of that, you can do it that way. We have our data in list 1, right? Okay, so that's what we want to do. So I've got data, mine's in list 1, frequency is 1, that's fine. What's my confidence level though? 90, so I got to change that. And then we're going to calculate.
So it's data and then one, and what's the frequency?
Just 1 for right now. Frequency, comes into play later. Like, let's say you have a huge list of data values, but you've got a bunch of repeated ones. Then you might enter it with a frequency list.
Okay.
But for right now, just that here. You want me to go back to it?
0.9.
Yeah, because this time we were doing a 90% confidence interval. Yeah.
If you weren't doing it through the calculator right away and you had to solve for the t-crit,
Mm-hmm.
how would you do that without the, I forget what the dx is.
Your degrees of freedom is always your sample size minus 1. So in this
Okay.
case, it'd just be 14.
Oh.
Yeah, good question. All right, are we okay? All right, so we got this interval 22.051 to 36.815. And this is what I was talking about. If you hadn't, like, you don't have to do the 1-bar stat separately. This will tell you every time what your X bar and standard deviation are, your S. So you don't have to do both of those things. You can just do one. So, good question. If you had stat instead, you would just put in what you know X bar and S to be and do it that way. So it just depends on how the problem is given to you. We were given a list of values this time, so that's why we did data. Sometimes you'll just be told in the problem, like, you took a sample, you got an X, you know, your mean of your sample was this, the standard deviation was this, and your sample size was this. Like, sometimes it's just all listed out for you. Okay. Yeah, so when it does, like when you tell it to find the t interval, it's finding the critical t value for you. Yep. All right, so my confidence interval was 22. I'm really struggling with my writing today, guys. 22.051 to 36.815. So the way you write, oh yeah, go ahead. Yep, either way works. Yeah, you don't have to write it both ways. But somewhere you've got to have your formula so they know that you know what you're talking about, okay? All right, so we would say we are 90% confident. That the true average percent increase in gas mileage using Gas Saver is between, and you could be as detailed as you want here. You could say between 22.051%. I'm just going to say between 22% and 37%. Questions? Okay, I know we need more practice, just like the mechanics of it and all the little pieces. But we have, let's see, I'm looking at my calendar back here. So we will have all of Tuesday to practice. We obviously have a little bit of time left here. And then Thursday is your AP Classroom quiz. I'll get that assigned to you ahead of time. And you'll have time to work on that. You'll have time to work on data journals, all of those things. Next week is a lot of just practice and working on stuff, okay? But that's the end of your notes, guys. Questions on anything? Are we feeling kind of here on it so far? Yeah. Yeah, I know. We need a little more practice. I want to give you your test back to see too, but let's wait till the end for that. So hold on. I know. Your scores have been sis, so you can see your score if you want, or at least your letter grade. Yes. Yeah. Really? There's no letter grade in there for you?
It doesn't say like late or not handwritten or anything. It
Just says nothing?
just says
Okay, hold on. Let me go back. Let me get this started and then I'll pull it up for you, okay? Yes. Guys, I'm going to have you start a quizzes with a partner here in just a second.
And just small like free time in this class because I want to get a class T-shirt before tomorrow because it's
Yes, it is
when we're supposed to
tomorrow.
wear it. Yeah.
Can you still get them?
In the activities office.
Oh, okay.
That's what.
Do you just want to run real quick?
Yes, it is.
Yeah, do that right now, okay?
Thank you.
Yep. All right, guys, so I want you to find a partner. One laptop per pair. I shut the timer off on it. You can have a group of 3 if you need to, okay? What is this? Some enthusiasm. Okay, good, good. You like those better than Khan Academy?
I'm really good on this. I'm not great on the test.
Maybe I'll.
The grade on my test was so good in my class that my grade went up and I got a B-. And my grade went up from B-. That's a bad grade. Like on a C+ I got in the first one.
Hey, we're making
I
progress.
just don't know. These class, if the test is like, I have no idea.
You know, there's a little bit of a learning curve there.
Open note test, that meant it was forward to.
No, no, not really something that's ever gonna happen. All right, guys, I got 4 teams. I'm missing a few. Join in, guys.
How many questions are on this one?
I think just 10, and a lot of them are kind of quick, like knowing what is the margin of error, what is the critical z-value, like not full confidence interval questions. All right, up to 6. I know Patrick's not here for you to partner with today, so. You're welcome to move if you want, or you can do it on your own. It's up to you. All right, guys, I am starting it. Jump in. Yeah. Oh no. Okay.
Said it was gonna be like parts of like instead of just full text, it would be like just circles for you.
Here's your code is still up here for those of you that need it. Do you need it?
Oh, 5%.
Oh, I didn't know.
You know, it was like, it's kind of cool. You know, it's one.
You get it's delayed.
Yeah.
I don't need
Oh, wait, you're actually, oh, wait, you're 35%.
Okay.
So this is the one that you're doing, 95, that's, oh, then you say 96, right? I think I wrote that in the time. Okay,
So would that be that'd
power up.
Wait, this delayed?
Yeah.
Yeah, because look, it's this, it's like a bean and it's like,
When we did the stack out or stack test, we weren't getting the
you don't stand. Yes, and we got
we did
So making it smaller, smaller. Why did biggest proportion of that is more so increasing.
Are we, is the thumb now going up?
We will go along. Oh my God.
Alright, we're done.
No way. No way.
So like do every
We had like double jeopardy.
Okay, okay.
So it was risky.
It is, that's like.
you guys it's normally not
So that's one of the things we solve for.
It's gonna be probably.
It was exactly
It's 99.7 and 3. You get double.
This feels like wait. Oh wait.
Today, dance team and cheer, we would have field practice after school practice. I like to like a few minutes I know, it's a really dumb problem. And everyone comes, like, I feel. That's a crucial thing. No, it's scary. You get stuck. It's like football gets the field at like 3:20 and we have to get off the field at 3:15, but it's cheer and it's all doing everything. It's just a very stressful week. It's so short. Like, well, it's just like we like move into the gym, but like we have to like block all of our formation. Exactly, and like because like we don't usually do stuff for cheer, and we haven't done this in 2 years. Like we only started learning our dance on Monday, so we've only had we learned the last half of it last night. So things are gonna be interesting on Friday to say the least. We're out here like out there in the morning blocking it all. I know. Well, that's what we should do. But like then both have gotten our coach gets mad because like she thinks that we get distracted. Just because we get like kind of embarrassed, so we're kind of like so yeah, yes. So okay, thank you. Like 2 or 3 minutes. Yeah.
Guys, we're just crushing it with the accuracy level. You're not alone. Just when you know it's early in the unit, guys. Early in the unit. Right, you're up there, yeah.
No. I think it's the opposite of whatever I think. I mean, isn't it this? Because as you're saying, besides the smaller, you're part of that.
It's fine, we can just try to resolve.
Yeah, but it's not the last one, or it was like that long.
Increase confidence level. Oh, increase sample size, and what about confidence?
So sample size is that.
Increase confidence interval. What is the margin of error? No. Yeah. The margin of error.
Okay, guys, you can keep working. I'm going to pass out your tests just so you have at least a few minutes here to look at them while you're still doing this. Obviously not for cooking.
Yay!
I'm going to distract at the end.
Oh, we can make it. Someone has played.
That was our next guest.
You know, I don't have to practice. Right there. Come on. Which one should I get wrong? Oh, well, so it's increasing the sample size.
Whether we're going to have
It's there.
Oh, yeah. Guys, look at your free response today. We'll look at multiple choice, like I'll go through answers for that for you on another day. Hold on, let me hit.
Oh, so the only